a shortcut to the stars, transporting us instantly into another part of the galaxy or perhaps another universe entirely. So these are all theories still, but that's the story. As you approach the Kerr black hole, you would pass through the event horizon. So you would never be able to go back to where you started unless, so remember, if you enter a black hole, you cannot escape it. So just be very certain before you do that. Unless there was another Kerr black hole that connected the parallel universe back to our universe, making a round trip possible. Also, there were problems with stability. One could show that if you fell through the Einstein-Rosen bridge, the distortions of space-time that you created might force the Kerr black hole to close up. Maybe it would close up, making a complete journey through the bridge impossible. As strange as the idea of a Kerr black hole was, acting as a gateway or portal between two universes, it could not be dismissed on physical grounds because black holes are indeed spinning very rapidly. However, it soon became apparent that these black holes not only connected two distant points in space, but also connected two times as well, acting as time machines. There you go, guys. Kerr black holes. So the fact that black holes bend space-time, yes, of course, from general relativity, we know that. Anything supermassive will bend space-time around it. That's the explanation of gravitation. Gravitation is not a force in general relativity, it's the bending of space-time. The sun is bending space-time so that we orbit it. Black holes are even more massive, depending on which black hole, and they would bend space-time a lot. I saw the question, but then it went away. Mega Ghost. Thank you for liking the live. 2 more likes, please. Then I get 20. Thank you. So the Kerr black hole is something that we're considering right now. So this is all sort of a theory in the sense of like, they're basically theorizing what if, right? What if we fell in and it connected to a parallel universe? Because the thing is that we don't know exactly what is inside a black hole, because if you pass through the event horizon, you can't come back. Even, remember, black hole is the object from which even light cannot escape. What that means is that we don't have information about the insides of black holes. So if we don't have information, then we can have imagination. And this is part of that. You can imagine these things, but I don't know if you can test them. You can contemplate these things by using your imagination. Well, we can't go the speed of light. We can go close to the speed of light, but we cannot go speed of light. We'd have to be light. So bending space-time has nothing to all massive objects bend space-time. So that's not a big deal. General theory of relativity is I don't know then. I don't know. Don't know. As strange as the idea of a Kerr black hole was, acting as a gateway or portal between two universes, it could not be dismissed on physical grounds because black holes are indeed spinning very rapidly. However, it soon became apparent that these black holes are not only connected to distant points in space, but also connected to times as well, acting as time machines. And this is according to this book, I'm not an expert in this, when Gödel found the first time travel solution, so this is Einstein's Cosmos by Michio Kaku, we're just kind of talking about a theory of the wormholes and such, parallel universes and such. When Gödel found the first time travel solution of Einstein's equations in 1949, it was considered a novelty, an isolated aberration of the equations. Since then, however, scores of time travel solutions have now been discovered in Einstein's equations. For example, it was discovered that an old solution discovered by W.J. van Stockum as an Stockum. I tell you some of the names here so that maybe if you're interested, you could look it up and even read some of these papers on your own. In 1936, actually allowed for time travel. The Van Stocker